Hey guys, welcome to our session on graphs. And today we will dive a little deeper and learn about the graph traversals, which are DFS and BFS. Basically, depth first search and breadth first search. Let's see what depth first search is at first. So, suppose you have a graph which has like nodes 1, 2, 3, then another one, 4, and then this might be connected as well. So this is an undirected graph, basically like all the nodes. So suppose you have one connecting to two, that also means that two will be connecting to one. And depth first search basically means that you will search along the depth first. Suppose you start from any node, call it a root node. Suppose you start from one, you will search for two, and then you will search along the branch and you will go deeper. You will go to its depth. So you will search for three as well and mark these as visited. And once you see that all of the nodes in this particular depth for your starting node 1 are already visited, there's no node further, then you will come back, which is not the case here, because like once you're going into depth, you will also see that 4 also comes into depth. Suppose you had a different example. So suppose you had an example of 1, 2, 3, and then like 4, just like this, right? Or like 5 as well. So here you would be searching for depth first search. Like you will go to 2 market visited, you go to 3 market visited, and then there's no depth further. So you'll backtrack, you'll see that both of these are visited, you'll backtrack, then you'll go to 4, and then you'll try to go deeper, but then there's no node. You'll mark 4 as visited, backtrack to 1, and then come to 5. And then as soon as all the nodes are visited, you say that you have traversed the whole graph. So this is the idea of depth first search. Do not think of it as anything complex, because I'll be showing you the code and explaining it. So let's look at the code here. This is a simple depth first search graph traversal. First, look at this function, because this is the main function and this is the helper function. So look at it afterwards too. Alright, so for the first one, you are given a graph, which is basically, as I said, if you are not told, it is an adjacency list. So I'm sorry. So you have a set of visited where you will keep all the nodes that you have already visited. Then for each vertex in list of graph, so suppose you have like A visiting B comma C, then C visiting B comma D. So for each vertex, this is basically kind of a hash map you can see in Python. So for each vertex means this A and C will be a vertex at the beginning. So for vertex in list of graph, you'll go to A. You'll check if vertex not in visited. If A is not in visited set, so suppose we have your visited set here, you will go to DFS helper with the vertex A and this vertex and this visited set. Now here you have V as A and visited set. Then you will add A node to visited. You will basically print. So we will basically print A, and then for every neighbor in self.graph V. So you are accessing a map at node V. So that means for B and C. So first B, then C. Now if neighbor not visited, if B not visited, you will call this helper function again with the B node here. Alright, you call it, you will add B to visited set, you will print B. Then you'll see for every neighbor in B. Alright, so now suppose if you had like B here and it would have gone to D or something, then you will have checked if neighbor not visited. If D not visited, then you will call it for D, because you are going depth for search A to B, then B to D. Alright, then you'll add D here, you'll print D, and if there's nothing, then your function will simply backtrack, and then you will come to the the other node, which is C. You will add C here, you will print C. Then for each neighbor in C, you will see you will first get B, but B is already there and visited, and D is also there and visited, so nothing will happen. You'll backtrack, you'll come back, and then you'll see for another vertex, which will be C. Now C is already visited, so nothing will happen. You'll come out of the function. So the basic idea is you have a visited set, you loop through each vertex, and then inside each vertex you add it to visited set, you loop through each neighbor of the vertex, these the neighbors, and then keep on adding them into, like, keep on calling the function again and again. So you're going depth first search. All right, this is the basic implementation. Try to practice this code and you'll learn it, and once you see this code in different questions, you'll get a better idea of how to use it and you'll get habitual to using it. All right, moving further, let's look at BFS. So BFS is much simpler to DFS. In BFS, suppose you have like this graph 1 2 3 and then 4 here. So BFS is breadth first search. You will basically visit the breadths first. So suppose you're starting from node 1, then you'll visit 2. Now you won't go to 4 as in depth first search. You will go to node 3 because you are trying to cover the breadth. Suppose you had like another node here 5, then you would have gone to 5. Then you'll backtrack, and then finally once you are on node 2, you'll visit its breadth, which will be 4. So the traversal will be something like 1 2 3 5 and 4. Suppose you had another node here like 6, then this would be coming in at the end. All right, this is the idea of breadth first search. Let's look at its code as well. And in this code, as you can see, we will be using a queue because we want to travel in a breadth first search. All right, again we have a visited set which is empty at the beginning. We have a queue which has the first node. So suppose queue we have A. We already added A, as this is the first node. We added A to our visited set, and then while there's something in queue, we will pop the first element. So you see, pop 0 means you're popping the first element. So you will get A, and then basically print A. You visited A, you print A. And then for every neighbor of A in graph S, suppose your adjacency list was something like A, B, C, and then B, C, D. Now here the important thing is you will first visit A, all of the neighbors of A. So you'll see you already visited A, then for every neighbor in graph S, so that's B. If B not visited, you'll append it and then add B to the visited. So B is there in your queue, this is popped out. Then you will pop B, you will print B, then you'll see for every neighbor and so on. So basically what this will do is you'll print like A, B, then C, and then D. Alright, this is the idea of breadth first search. Let me know if you have any questions, and as you solve more questions, you will get a better idea of these. Thank you for watching and see you in the next one.